All right. So thanks for joining. I'm going to be covering a bit on the P300 tool that we've released. This was work done by Shahid Murji over the summer. So I figured we'll start sort of from the beginning and we'll work through. I'll cover the basics beside it, or behind it, I guess. And any sort of questions you guys have, we have people monitoring the Discord chat as well as the YouTube chat. So post those up as they come up and I'll be happy to answer them. All right, so this was the scene that Kyle was using earlier. We'll come back to that probably, but I will pull over our Brain Computer Interface BCI Game Jam itch page. So the P300 tool, in case you haven't done it, we can download here in the GitHub. All we really need is this Unity package. I also have a pretty in-depth README to make sure that it's up and running for you. But the key points here to sort of recognize is that you should be trying to use a Unity version 2019.2 or higher, as certain parts of the package manager may not work. We tried to get this to work with earlier versions of Unity, but it was not having it. So when importing the package side, it will create some errors. So just go with 2019 or higher, which is great. Eric, feel free to interrupt me with questions at any point, by the way. Great. So then in the actual package, you will get a couple of key variables already set up, as well as a demo scene. And this is really important because it gives you sort of an idea of how you can manipulate the code on the back end to implement it into a game-like scenario. So let's go ahead and download this. Perfect. And I'm just gonna save this into downloads, that's fine. And then I'm gonna go back to my Unity. This is the one that Kyle was working on earlier. He just has camera controller in here, and we're gonna go and do assets, import package, custom package, and we're gonna go to where I had downloaded that. So I threw it in downloads. Great, open, preparing, and should update here. Do you know if it updated in, Kyle? I imported it through assets.
So
doesn't seem to have imported. It might also, just so we're clear, it also might have been downloading still. Shouldn't have taken that long though.
well, you have two instances of Unity open.
Right, it's definitely in this one though.
So, okay. Let's sneak in there.
Okay. Actually, you know what it is probably? We're on 2018, which is a good example of not doing this.
Shouldn't matter.
Yeah. All right. Kyle's gonna join and help.
So it should recognize. Where do you have it downloaded?
Just under downloads.
Oh, so here's the
Oh, didn't even see it.
dialog for it.
Yeah, no, sorry, that was on my side. It might not work, as I warned, it's on 2018, but we'll find out real soon. I'm not used to streaming, and there's a second monitor, which it popped up onto, which I didn't see. So in here, you have the demo, as I was highlighting before, as well as materials used in that demo, and the demo scene, which you can learn quite a bit from, textures, etc. And then the main scripts that you guys will be interested in are the P300 flashes script contained here, as well as the inlet P300, which is up here. inlet P300. So those are the two main scripts that are needed. So we're going to click import. We're going to see if it breaks. We were having issues in 2018 before. Reload, that's fine. Perfect. Great. So here it's imported that whole package for you. There's a couple of different scenes. So if I load just this scene, I'll save that, that's fine. So this is my default scene. Under marker streams, this is the thing that is actually sending out the information from the EEG and is being paired with that through your GTEC system and through something called lab streaming layer. So over here, I have a folder. Lab streaming layer is just online. This is a very, very common backend solution to synchronize stimulus and EEG. They do a lot of work with a whole bunch of systems. So if you don't have GTEC or any of these other ones, they have a bunch online. I'll actually pull up their GitHub. So if you just look at lab streaming layer, GitHub, they have their apps folder here, and they have everything from Biosemi to brain products, cognionics, basically any type of BCI related system, EEG related system, and other ones too. Like you see a Wiimote down here, which is quite fun. I haven't tried the Wiimote or anything like that, but they have a bunch of different libraries for you, and all of them do the same thing, which is they pair and synchronize what's happening in your software with an EEG recording and try and get rid of any sort of jitter and changes that can be happening. So that being said, we go back here under lab streaming layer. We're using the GTEC USB amp. I actually don't have it with me right now, or I'd run the full thing, but when I run this as an admin, you'll see it pops up with this little connector here. It's going to be looking for 16 channels. I can rename those. Right now they're just channel 1 forward, but rename them to actually what is on the EEG cap, whatever layout we're using. And then I'd click link, get an error because we don't have that up. But all of this is what's being taken care of and being sent through this marker streams here. So here you have LSL marker stream. You don't even have to worry about that. That is taken care of on the back end. It's going to send everything that's happening in your Unity scene out to that lab streaming layer software and then forward that basically to Matlab. On the other side, just below that, is this inlet P300 script. This is what then listens from Matlab, which is will decide what actions to take, the different back-end processing side of the brain software. And it says, okay, what are you looking at? What are the features you're using? And what do you want to send back to Unity? And that's what the inlet means. It's getting that information coming from Matlab, and what do you want to do with it? We'll step into this in just a moment and talk about the only real place that you guys need to make a change here for it to actually work. But it's just good to know that out of all the different things that are included, you only need to change inlet P300 and P300 flashes. So we tried to make it as streamlined as possible, so you know that. We even included just those two scripts at the very top of the package manager, so you can say, okay, great, I know exactly where to go. So then the other thing that will pop up here is this game object cube controller. This is equivalent to a game controller or anything that you want, since this, in this case, only is running a population of cubes that are being instantiated. It's called cube controller. But we have over here the main key script that's associated with it, which this is what controls the actual stimulus side of the P300. So this refresh rate is a little outdated. It's for if we extend it to steady state visual evoked potentials, or SSVEP. Don't worry about that, it'll auto-populate. The frequency, this also, you don't have to worry about, it'll auto-populate. But you do need to put in flash length number of samples, and then starting position, or not starting position, distances for this to actually run. So flash length here is how long the actual cube will stay illuminated for. So right now it's at 0.1 seconds, which is quite fast. So it's nice to get it at 0.2. Number of samples, every single cube will be flashed at least 10 times. If you're flashing them independently, that'll take quite a while. If you're doing rows and columns, that means every row and every column will flash 10 times. So it reduces the total number of flashes that are required, and I'll show what that looks like in just a bit. Starting positions, this is for if you want to instantiate somewhere in the world space that isn't necessarily directly in front of the camera. You can tell it where to start. And then you have your distance X and distance Y. These are referring to the distances between the different cubes and the length between them. If you say want your selection panel as maybe sides, like different side panels, then you can extend your X distance between the cubes. Or if you want them top bottom, you can extend the Y distance. Similarly, you can change the number of columns, number of rows, and it'll give you that number of cubes per column per row. So again, if you only want 2 on the far sides here, then maybe you want 5 selection points along the corners of the screen, but only 2 columns. So you change that to 5 and 2. And you'd make your distance here maybe 5. So we're gonna hit play and see if it crashes. Hopefully it doesn't. Oh, good, great. So now, as you see, it has instantiated our 5 rows and 2 columns. And we say, okay, well, we don't really like that distance. We wanna increase it some, so I'll increase it to 7. Built into this are some key script commands. So S does single flashes, R will do row column flashes, D, if you make a change like I just did here, you hit D, it'll redraw it for you right away so you can get a feel for what it looks like. And then Q is for actually quitting the program. So in the console here, you'll see that we print out all these details to Lab Streaming Layer. So on the back end, our marker streams has created this stream called marker, and we're sending that out, just broadcasting it to the world, and we tell it about everything that we've done. So we say, okay, here's the camera position, here's what single flash details will look like, here's what the row column flash details would look like. We're saying 10 flashes, we want 5 for each row, 5 for each column. And then down here, when I redrew that, it just sends it again and updates it. So it's useful for especially trying to figure out how you want to lay these things out in your game. Quite nice. And so I like that. I want it a little bit further still, so we're gonna go with 9. I'll redraw, great. I think maybe 5 rows is, 5 rows is fine. And so if I hit S, you'll see single flashes starting to happen. And here it's printing out what the name of each of these cubes are. So this will always start with 0 in the top left and then read left to right. So this is cube 0, cube 1, 2, 3, etc. down the different rows. So you see it just prints and prints and prints for a long time. This is useful on our side because all of these are being sent to Matlab, which is then we will say, okay, what was happening at that cube and what was happening in the EEG data? Is there a P300 event occurring or not? As you're about to see, that took, I don't know, 15 seconds, probably a bit longer. If I now do row column instead, it goes much faster. So now it's grabbing each one, going through and making sure that each cube is highlighted 10 times total. Perfect. And maybe we say, all right, that is flashing a bit slowly. If we drop that back down to 0.1, and maybe we want it to go even faster, we only want 5 samples. I redraw, and it goes much quicker now. The issue or the concern there is the faster that you do those, since we're looking at certain windows, you might get overlap, and so it can lower your accuracy. So I think a good starting value is 0.2. I found that to work pretty well. So again, this is at 0.1, 5 flashes each on here. And as people always ask, they want to know, well, how big can you make this? It just auto populates for as big as you want. Maybe we won't go that big. We'll do a 10 by 10 just so you can get a feel for it. We're gonna keep the size between them quite small. And now you have this huge grid to select from, kind of like Minesweeper, if anyone wants to make a P300 Minesweeper, which might be a fun idea. Single flash is going to take a long time to get through all of these, so keep that in mind, that the bigger your grid, each one has to be printed at a given point, and it can get quite exhausting trying to focus, say if you're focusing on that one there, for this entire time. If I hit S again, it'll stop it, but that is an overview of the P300 CubeSet here. Just to walk you through the actual scripts, if I open your P300 flashes, you'll get a sense of everything that has been written here. Here's all those public variables that you saw. This is just sort of letting you know the order that the columns are being registered. So C00, 10, 20 down to 22. You have all of your Booleans there, and really there's not much here that you should have to change. If you're interested in swapping it so it doesn't have to be instantiated on start, I would recommend to check out our demo scene. So here I've clicked under P300 Unity into the demo folder, and you can see scenes here, also demo inlet and demo P300 flashes, so you can quickly see what that change looks like. So I'm going to load the demo scene. I'll save this because it's fine. And so this might be where the issue is in the demo scene. There's supposed to be here some default images that you can see. So they don't auto-populate. Yeah, it's missing its overlay. But that's okay. It has, in the demo materials, you have what are these sprites that should be linked up to this. So if I just go ahead and make this 9, I can pull over whatever sprites that I want. So I'll throw 1, 2. You know what? Let's just make it 2. Make my life easier. So we did the down and the up. Great. And it should have been starting there. So yeah, I'm not sure why, but it works in 2019 at least. 2018, this was where we were having issues coming in. But it would give you an overlay there so that when you hit start, it would run. Again, in the console, there's the issue of it being connected up. But on the plus side, you don't have to actually run it to look at the script itself. And you can see in the demo P300 flashes, if you go down, all of these here, the dynamic parts are commented out for you, so you know, okay, how did they do that before? Initializing the matrix, etc., is not needed. Here's the functionality for the redrawing matrix that's taken out because these sprites are existing in the game at the moment, versus in the standard P300 script, that's all left in. So you can look between the two to get a feel for, okay, if you want to dynamically generate these objects, then you have the P300 flashes script normally, but if you want them to already be existing in the space, then you have your demo script here to take a look at. that's about the most different aspect in terms of the demos. I'll show you quickly the inlet part, because this is the main thing that we want to have you guys be controlling. So first off, note, we're going to be releasing a change here, but one hard code line had gotten through on this release where it's looking for something called cube controller. So this line here is saying, okay, find game object called cube controller directly. If you import that into your game and there's not something called cube controller, it's going to fail. Took us a while to find where that is. So we're going to release a push later today, which takes care of that, or you can just name it. Here it's line 33 in inlet P300. Name it what you're looking for, or do the get component of type P300 flashes. So if you change that to game object dot find component of type, find object of type, not find component. So you'll have to cast it, but you can do that yourself, or leave it here and say, okay, we're just looking for a specific name. We're going to do a push that will work for any game, but that's later today. The only other line that really you guys need to worry about is down here, starting at line 57 in these if clauses. This is the entirety of your game's logic coming back through. So we're doing another update where we will print out the cube index and make that available from the P300 inlet script. But if you want to change it within the classifier lines yourself, it's quite simple. This is just asking MATLAB, was it a single flash or was it row column? If it was a single flash, then this line here, line 61, it just changes material to color green. So all you have to do is implement in what your actual code or action is. Similarly, this happens now for row and column, exact same things. I'm going to show you an example in the Mario Matcher game that I made to highlight what that looks like when that's actually changed. So I gotta bring it up first. While I'm doing this, are there any questions?
From the Discord or the chat that I see.
All right, we have a question here in the audience.
Okay, so why would I ever use single flashes and not row column if it's faster?
That's a great question. Say you have 3 options and you want them all laid out at the bottom, then it can be easier to do the single flashes there because you get more opportunities to see each of the items. So you have a better or a clearer difference between target and non-target.
Okay, but in the grid formation, row column is just superior? It's just faster?
It's faster, yeah. But, I mean, yeah, it's faster. It's nice to have both options in the sense that sometimes you'll want to have a bit more control over that. So again, if you're training, it's nice to be able to train on a single cube at a time without worrying about, okay, were the neighboring ones flashing at the same time and they're very bright, or any of those sort of like potential mudding effects.
Okay, so accuracy should be higher on single flash.
Should be, but it's faster with the row column.
Okay.
But don't hold me to that. It could be different.
I'm holding you to it.
Oh no. Okay, great. So I've loaded up this Mario Matcher game. I talked about it yesterday some. We have basically, will the audio play if I go? Okay, so basically I've set it up with just a very basic demo to show how it goes. I'm gonna mute the audio at the moment, but there's some copyright infringement that's happening. Don't worry too much about it. But the way that I've set it up is to test. I have a script on each of these cubes. So here's my cube list that gets generated. On each cube, I have this script, which I'm calling disappear on click, which is the actual action that I want to have happen when someone focuses on one of these getting highlighted. So I've set it up so in my debugging, I can highlight and click and it happens. And what I've done then in the P300 script inlet, so I go here to my marker streams component, I go to inlet P300 and I open this. I have gone to that line, so here you can see I changed it to P300 controller so that will work. And I go down to if classifier S, here's all that same information as before, but now I've removed from this inlet P300 here the kubelist.getComponent color green, and I've replaced it with a set of logic that eventually calls my disappear on click script and the function in there called mouse click. So I set that up, I debugged it using my mouse for quite a long time, and then when I was ready and thought, okay, perfect, we can go ahead and use this, I switched it to this script. Perfect. Yep, we have a question from the stream.
So we have two different questions, one from YouTube and one from Discord, both referring to the Matlab file.
Okay.
Eric Wells asks, do we have access to the Matlab script communicating with the Unity script? And Matt asks, where is the Matlab file?
Yeah, so I can send the Matlab script. Basically, what I can do is I can zip up all of the Matlab information. We're using something called EEG Lab and BCI Lab. Both of those are quite complex backend things, and there's a little bit of nuances that has to be run with this. If you have any experience with Python or EEG processing, you can realistically get the same output from using LSL for Python. So all you have to do is listen for that in Python and then run a group which is called MNE, and that will give you that Python script. But I can upload our Matlab scripts. It's just a few independent changes to the BCI Lab, EEG Lab. I'll pull that up right now. So we have Matlab up here, and you'll see kind of what you have to go through. So all that will be included in it is this, okay, this test controller script here. This was written by Shahid with my help on it, and it mainly sets up the LSL inlets and outlets, but it requires you to have very specific functions downloaded and added to your path. That can all be included in the manual for it. And so in the Matlab world, I would run, okay, test controller, and then I'm doing all these inputs that they have of type. So you can say single flash or RC flash for row column flash. And then for setup, you can either have it be false, which means don't need to reset up BCI Lab and EEG Lab, which you have to have downloaded and on your path. If you run true, as I have here, set up true, then it's going to open all those up. And then you have to have your calibration data, which is recorded separately using this lab streaming layer information. So let me pull lab streaming layer back up. So in lab streaming layer, what you can do is you can open up lab recorder. This is going to just listen to, so I have to run it as admin because it says, hey, look for an app. And I say no. But I'll pull that up and let you see what it's looking for. Yes. Yeah. So you record your calibration data earlier. Okay. I would show you the full demo, but we are actually using our GTech software at the moment with one of our patients at the hospital, so that's not coming back for a little while. All right. So this is Lab Recorder. You can see the marker stream. As earlier I said, when I hit play, it creates this marker stream that is on the lab streaming layer software. For GTech, you'd also have a stream here that said GTech USB amp and GTech marker. You don't want the GTech marker, you want the one from Unity. And then you can choose where you want to save this information. So throw it under documents, wherever you want, or desktop. And then this will record the EEG and the markers simultaneously through lab streaming layer for you. Anyway, that's how I got this training data here. They save it in a .xdf format. So it's compatible with some software. Other ones don't like .xdf as much. If you've used NeuroPipe, there's an error that sometimes happens with that. And then your training sequence that happens. So here, this is actually my data from a couple days back. I was using the P300, the main P300 tool there. I just recorded from top left, so I'm gonna hit play quickly. I recorded from top left, middle. So I did 1, 2, 3, 4, 5, 6, 7, 8, 9. So those were the 9 that I recorded in a row. And so 0, 1, 1, 4, 7, 8, 5, 2, 3, 6. Because remember, it starts at 0 on the top left, so it runs to 8. So then I hit enter, and this is gonna just run for a while because it has to set everything up because it's the first time. Meanwhile, okay. So I'm gonna quit this for now. So I hit Q, you see quitting program, but there's a whole instruction thing that I can add. So this was adding all the EEG lab profiles. And yes, this is a long story, but we can provide this to you guys happily. The main benefit is the P300 Unity tool should be able to work with anything that you do your EEG processing with, as long as it uses lab streaming layer, because it's just looking for you to output a stream to lab streaming layer. And so you say, okay, I'm looking for this stream because it's a publish subscribe model. So it publishes a stream, which is called marker in your EEG processing. You say, okay, pull in the stimulus that's from marker, do processing, and then output a stimulus that's called BCI continuous or BCI info, something like that. So here it's now loaded all of EEG lab and BCI lab. You can see it says fold. This is where they were using my data that I've recorded to do 5-fold cross-validation. I got 25% error rate. I was using only half the plugins needed. It says setting up new outlet for Unity, getting information, and then loading the library, resolving the stream. That was the marker stream that you saw earlier. Opening an inlet, receiving information. Problem being that since we don't have the GTech cap, as soon as I run it, so if I go like this, and I run, it's going to be looking for the EEG data before it actually does anything. So it's just going to sit there and wait. Where I'm saying it's a bit finicky, as you will see right now, because it's constantly listening, there's not a good way to break out of this while loop. This is something that has to do with lab streaming layer in Matlab and it being a bit older. I have to hold down the cancel button, so that's Control C, until it eventually finds it, or I hit Alt F4, which isn't great. It's not the best use of how to do it. But I'm gonna quit here and close that for now. And that's fine. Yeah, so as you can see, it's not even listening for my cancel. So I have to Alt F4, stop now and exit. Then reset it back up. But yeah, happy to provide that. And you said there was another question, Eric?
No, that was it.
Great. Yeah, so that's a bit of a broad overview of it. I'm here throughout the weekend and happy to continue to work on this with anyone who's interested after the game jam as well. But yeah, let us know. Thanks so much.